Welcome to the first week. In this week, we will be going over digital input and output, as well as basic electronics prototyping. Let's start off by talking about the breadboard. Yum! To get a breadboard, go to this side panel here, and drag out Breadboard Small. I don't really like this orientation of this breadboard, as the letters are rotated 90 degrees. To rotate a component, select the component and make sure you have the blue border. It means it's selected. Then press R. Okay, now let's talk about the layout of the breadboard. So the breadboard can be separated into two portions. There's this outer portion and there's this inner portion. The outer portion is connected vertically, as you can see when you hover over the holes. And the inner portion is connected by rows, separated by the divider. The outer portions, which are connected vertically, are referred to as power rails, as they're usually where you define where is high and where is low, high being positive and low being the negative. So let's do that. Scroll down in your sidebar until you see Arduino Uno R3 and drag it out. Now let's connect them. So I want to connect this 5V over to this positive rail. To do that, just click on the 5V. You can turn the wires by dragging it out and clicking again. It doesn't really matter what color the wire is, as all wires conduct electricity and they don't really care about color. But in this case, I'm going to be changing my ground wire to black and my 5V wire to red, as it's convention. And it makes it easier to see. As you can see, this is red and this is black. So that makes sense. Now let's connect an LED to the circuit. To do that, pull out an LED and give it a few rotations. The LED has two ends, a cathode and an anode. The cathode is the negative end, and the anode is the positive end. To remember this, just remember that cats are generally pretty grumpy, and so they have a lot of negative energy, and you should connect them over to the negative side. We can start our simulation by pressing Start Simulation. And it exploded again. Let's hover over the LED and find out why. So it says that the LED is receiving 483 milliamps, while it should have been receiving at maximum only 20 milliamps. To solve our problem, we're going to need the help of Ohm's Law. V equals to IR. The voltage is proportional to the product of the current and the resistance. As our circuit has the voltage fixed, in order to decrease the current in our circuit, we would have to increase the total resistance. To do this, we could connect a resistor in series, as the total resistance of components in series is just the sum of all their resistance. The meaning of connecting something in series just means that the path that the electricity would have to take through one component is the same as the other component. As you can see here, you would have to go through R1 before you can reach R2, and before you can reach ground. Now when we run the circuit, we shouldn't get that warning anymore. And great, we lit up the LED without making it explode. Now let's get to the interesting part, the Arduino. All Arduino code requires two main functions, the setup and the loop. The setup will be run once when the controller is started. After the setup is done running, the loop will then be run repeatedly. Now let's take a look at some basic methods you can use in your code. First off, you want to declare your pins as either input or output in your setup. To do that, you will need the pin mode method. The pin mode method takes in two parameters, the number of the pin you wish to set and the mode you wish to set. This will either be input or output. If you are using the Maker Uno, there is also an input pull-up option to set the pin to receive input using the built-in button on the board. Next is the digital write method. This method writes either high or low to a pin that you specify. The syntax is pretty similar to the previous method. It takes in a pin number and the value you wish to set, in this case being either high or low. So now we have the methods we need to write some basic code. First, let's wire our LED such that it receives input from pin 8. So let's delete this wire over here using backspace and connect this rail over to pin number 8. Okay, now let's open the code editor by pressing the code button at the top navbar and change our mode to text. You can code in blocks if you feel more confident using them. However, the code blocks have limited functionality, and you would want to be coding in text as you start to make more sophisticated projects. Now let's clear the defaults. So in the setup here, we're going to be declaring pin 8 as the output. And then in the loop, let's write to it high. And then set it back to low. Now let's try to run our circuit. The LED is always lit. So, what's going on? The reason that the LED is always lit is because your microcontroller runs too fast. The Arduino Uno runs at 16 MHz. That's 16 million instructions per second. That means that even though it is looping between high and low, it is doing so every 1/16 millionth of a second, and thus we are unable to observe it. To fix this, let's add a delay to the code using the delay method. The delay method just takes in one parameter, the time you wish to delay in milliseconds. Simple enough. Let's add a 500 millisecond delay after the high and the low. This should make it such that the pin changes state every 0.5 seconds. Now when we run the circuit, the LED should blink. Now that's much more interesting than it just being on all the time, right? Now that we are familiar with how to output, let's write some code to receive input. To do this, we'll use the digital read method, which takes in the pin number and returns the state of that pin. Let's hook up a button circuit to provide input to our Arduino. To do that, let's make a connection from the power rail to ground through a button. You can copy this resistor using Ctrl+C and Ctrl+V. Let's connect the power rail and connect the button. So we use a resistor for the connection to ground so that when the button is pressed, the voltage will drop across the resistor. This is so that there isn't a direct connection from the power rail to ground, as this can be dangerous and is a short circuit. Now let's pick our input pin to be 5 and connect it between the resistor and the button. Let's also connect an LED to the circuit so we can get an indicator of the status of the pin. To select two components, select one component, hold down Shift, select the other component, Ctrl+C and Ctrl+V, and you'll copy both components. Nifty, right? Okay, now let's hook this up. Okay, the alignment made it that I couldn't press this hole, so I had to press into here. But if you're doing this physically, obviously you can't put two wires into the same hole, so you're going to have to connect it here. Either that, or you could connect it here as well, under the resistor. Now let's write some code using the input. For this demonstration, I am going to be alternating the LEDs, so I want it such that when 5 is low, 8 will be high, and when 5 is high, it will be low. To do that, let's first take out the delays. Let's move this up to a higher hierarchy using Control and the right square bracket, and use the if condition. So if what I happen to read at pin number 5 is equal to low, I want to be setting it to high. Else, I want to be setting it to low. Okay, now let's run our circuit. And great! It alternates the LEDs. In this video, we covered digital inputs and outputs, as well as basic electronics prototyping. Being able to deal with high and low has its uses, but sometimes we might want to be dealing with a larger range of values. In the next video, we will be going over analog input and output, which will allow us to read and write values in between 0 and 255. Hope to see you there!